Let us understand the steps required to partition a directed line segment in the given ratio. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll have very important question based on partitioning a directed line segment. Many students find this topic challenging. We'll show you the best way of answering such questions. We'll consider two examples. Example 1 here is, find the coordinates of the point P that partitions the directed segment AB into the ratio of 3:1. So we're given the graph. You can take the endpoints from the graph and then find the point P which will partition this segment in the ratio of 3:1. Second question is, find the coordinates of the point P that partitions the directed segment AB into the ratio of 1:2. So this line is going down. So one with a positive gradient, the other one is with a negative gradient. Let us see how they are similar and how they are different. Now, the common formula which is used for such applications is also given here. So we are talking about directed lines. That means we know the direction in which we are moving, A to B, correct? Once we are given the coordinate points x1, y1 and x2, y2 with the ratio m to n, in that case, we find a scale factor m divided by m plus n, and we can use this coordinate point formula to find directly the value of P. But before getting into this formula directly, it could be confusing at times. We'll actually understand the concept and then get back to it, okay? So here is our first example. Example 1 here is, find the coordinates of point P that partitions the directed segment AB into the ratio of 3:1. So the direction is from A to P. So we are going to add all the values to coordinates of A, right? So coordinate point A will be called as x1, y1, and B is going to be x2, y2. We are given this graph. Point A is -8, -7. So let's write down. A is -8, -7, and B is 8 and 5. So these are given points. The ratio is 3:1. So let's write down the ratio also. So ratio here is 3:1. So when the ratio is 3:1, we have to divide in 4 equal parts and take 3 out of them. So that is equivalent to 3/4. Is that clear to you? So 3/4 of the run and 3/4 of the rise. This is what we are going to take. So let's figure out what is the run. So run will be horizontal distance as you've seen here, and the rise will be the vertical distance. Perfect. So let's figure out how much are we going to add to these values of x. So basic formula for getting the point P is x1, the value of A, plus 3/4 of run. And as far as the y coordinate value is concerned, it will be y1 plus 3/4 of rise. Is that clear to you? Change in y. So this is change in y, delta y, and that is change in x, delta x, which we are calling as run. So let's calculate what is run and what is rise. So the run is basically x2 minus x1, which is equal to, from these points 8 minus 8, right, which is 16. And the rise is y2 minus y1, which is 5 minus 7. So which is 5 plus 7 or 12. Do you see that? So we got our rise and run. Now we'll substitute these values in our formula. 3/4 of this, right? And calculate. So the point P should be x1 is minus 8. We take it the coordinate from point A plus 3/4 of run, which is 16. That's the x coordinate value. And the y will be minus 7 plus 3/4 of rise, which is 12. So let's calculate these values. So P will be minus 8 plus 3/4 of 16 means 16 divided by 4 is 4 and times 3 is 12, right? And the y value 3/4 of 12 means 12 divided by 4 is 3. 3 times 3 is 9. So we'll add 9 to this. So we get this point P coordinate value as minus 8 plus 12, which is 4. And y value minus 7 plus 9 as 2. So 4, 2, correct? So x value 4 and y value of 2 gives us the point right there. Do you see that? So that is our point P, whose coordinates are 4 and 2. So 4 the x value and 2 is the y value. You understand the whole process. So what we did was we calculated the run, which was from here to there, right? This much. This run is 16, right? This was 16. We took 3/4 of 16. So times 3 by 4, which is 4 times 4 goes into 16 times 3, which is 12. So that is the 12 which we added to the x value. Is that clear to you? So going 12 units from here, which is up to this point. And then on the rise, we calculated the difference between 5 and minus 7, which was 12. So we took 3/4 of 12, which is 9 units above. Okay? So we reached this point. So that is what it is, correct? So we got our point P. Is this clear to you? Perfect. Let's do one more example just to confirm. So here's our second example. I'd like you to pause the video and answer this question. Let me write down clearly the points given to us. So point A, which we have is minus 4, 4. Point B is 2, 1. And the ratio is 1:2. That really means 1/3, correct? Now consider, because it is directed from A to B, so this will be considered as x1, y1, and B is x2, y2 for us. So point P is the A value x1 plus 1/3 of run, correct? And y coordinate value of x1 plus 1/3 of rise. Is that clear to you? So let's calculate the rise and run. As you can see, the run here is, so that is what we have, right? Correct. So let me write down the calculations this time on the graph itself. The run is x2 minus x1, x2 being 2 minus 4, correct? So 2 minus 4 means 2 plus 4, which is 6, clear? So the run is 6. So we can write the value of P as x1, which is minus 4, plus 1/3 of 6. Correct? Now let's see the rise. Rise is, it goes to 1, right? So it's actually negative 1 minus 4, which is minus 3, right? So rise is minus 3. So y1 is 4 for us. Since the rise is minus 3, it becomes negative here. Do you see that? 1/3 of 3, you can see, right? So I made this, or you could have written like that. You understand? We have to go down. Okay. So now the coordinate point is minus 4. 1/3 of 6 is 2, right? And 4, 3 divided by 3 is 1. So 4 minus 1. And that gives you the point P. Let me put it in a different color. So point P is minus 4 plus 2 as minus 2. And 4 minus 1 as 3. Correct? Makes sense? 1/3. So minus 2 is right there and 1. So that is the point. Is that clear to you? So this becomes point P for us. Correct? Whose coordinates are minus 2, 3. Makes sense? So you can see these are the 3 equal parts, right? So we have divided the line segment from A to B in 1/3. Do you see that? That is the point P. So that is how it should be done. So I hope with this you have also understood the method, and here is the formula which we actually apply. So partitioning a segment on a coordinate plane really means dividing the directed line segment in the given ratio. If point P divides directed segment from A x1 y1 to B x2 y2 in the ratio of m is to n, the scale factor is m divided by m plus n. And the coordinates of point P are given as follows. So starting from x1, the first point, in this case happened to be A, plus the scale factor k times x2 minus x1, this is the run, right? And y1 plus k factor times the rise. Absolutely clear? So that is how the formula should be utilized. Perfect. So with this, we come to an end of this particular video. I hope you have understood the concept behind partitioning of directed line segments. You can always call on me on this particular email to learn more. Feel free to write your comments and share your views. In case you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.